Don't get me. Just get my hands. All right, we are here today to go over some basic RF testing principles. Okay, first of all, you will have your RF testing unit. In this case, this is an older model, and then Ritsu Sightmaster 331B. There are newer models that come equipped with 3D screens and color LED display board. Unfortunately, today we won't have to deal with the basic black and white. First thing you do, you power up your unit. It will come on. It will display a basic screen wherever you left off from the last time you performed testing. You will then hook up your null modem test cable to your RF port in the back. It's pretty self-explanatory. All right. Once you have your null modem test jumper hooked up, next thing you want to do is select the frequencies at which you're going to be testing. In this case, looks like the last set of frequencies I was testing at was the 800 LTE frequencies, anywhere from 8 to 900. I have these frequencies presently set at from 810 to 900. The next thing you want to do is set any markers. In this case, today we are going to test a jumper for network vision installations. Each jumper in the site install has to be tested. The level they're looking to receive, the customer, is a neg 20 dB. So what I'm going to do is set my marker limit at neg 20. So what you want to do is go to a limit, which is number 7 on this particular unit. Okay, you want to limit the edit, so you push the button next to that. And right now my limit is set at neg 14, which is for the system suite. But I'm just going to change that to 20. Okay, and press enter. Okay, this horizontal line going across the screw is your limit line. Any test frequency we get above that limit line means it fails. Okay, so I pressed enter. I want to go back to RF suite. Okay, and my limit line is set at neg 20. Now what I want to do prior to performing any test, you want to calibrate. So now we go to start cal, which is the number 3 button on this unit. You press that. Okay. Down here you get a set of instructions on the unit. It tells you which part of your calibration equipment to test first. In this case, it says connect your open to the RF port. Okay, here we have a calibrated T. Each part of the T has those units: a short, a calibrated open, and a simulated calibrated load. So it says to connect to my open side first. This is my open side. Okay, so we're going to connect to the open. And what this does is take out with any imperfections in this test jumper out of the levels from your test. So we want to use this one because we're going to keep this on while we perform for the jumpers. So I'm adding an adapter to plug into my test jumper, inline test jumper. So that's all going to my open port of the calibrated T here. Calibrated T. That's what this is called. Okay, now I'm going to press open. There's going to be a suite testing at open. Okay, you get a prompt to go to the short. Okay, now we're going to the short side of the calibrated T. Okay, we're going to press enter again. And the unit is measuring the calibrated short. Okay, and last but not least, we're going to the calibrated load or termination. Okay, it's the last part of the T. Press enter again. The unit will take these measurements into calculation. Okay, now it's doing a test sweep across the bottom of the unit. It's nowhere near our limit line, which means we're in pretty good shape. Note our limit line is way up here. I might have picked up me talking, but that's okay. I'll perform a dummy sweep with the load still on. Okay, it's got hold up here. Now we're going to perform an actual test on the jumper itself. Remember, this jumper should be greater than neg 20. So we're going to actually leave this adapter on the test cable into the jumper. So we're connecting our unit testing jumper into the site jumper, one of many. According to the new sprint work, we can have up to 51 jumpers. So this will have to be performed 51 times. Now I have to connect the load on the other end of the jumper. So I'm going to have to change my adapter. I'm going to use the load side of the T. So connecting my adapter to fit my load and to fit into the jumper. So now I got my calibrated load on the end of the jumper. Okay, we're all set to perform the test. On the test unit itself, we're going to go to the mode button on the bottom of the unit. Make sure you see my finger. Go to mode. Now we're going to scroll down. In this case, we are where we want to be on the return loss. That's one of the prescribed measurements for this customer. So it's highlighted already. Return loss, if I wanted to move it up and down, there are arrows to the right of the unit to scroll down to the different selections. Once return loss or your prescribed selection is chosen, you press enter. And now the unit will perform the sweep. Note if any part of that that sweep goes above that limit line, we are back. Okay, as you see, none of the waveform exceeds our limit line. Now what we can do is we want to set a marker to prove that we are less than or greater than the neg 20 prescribed mark. So we go to the number 8 key, which is also marker. Okay, we go to marker 1. So that's what I have. We want to go to marker to peak. That'll measure the highest point on that waveform. Okay, and right now, if we read the bottom left of the screen, you can see M1 is at 23.88, which means we meet and beat our 20 or better dB mark for this jumper. So in this case, this jumper passes. It is good. So we want to save this sweep. So now we go into save mode, which is number 9, save display. And we'll label this particular sweep with the site number. In this case, we'll leave that site number the same. And we'll just say it's for whatever sector. Anyone can label these any way he wants, as long as he remembers how he labeled them or his labeling system prior to output for closeout. So in this case, I'll just pick an A for alpha. I'll create a space, and I can just say jumper 1. So I'll pick a J for jumper, and I'll push the 1 button for 1. Now, since I know I'm in the 800 frequency, for network vision, there were only 2 800 jumpers. Well, actually 4, but like I said, it dictates by your noting designation. So in this case, I'll just say this is one of the 2 going to the antenna. So if I'm naming this one 1, I know the other one is 2. So in this case, I have for site number, sector, and then jumper number. And then once you put that in, just press enter, and that sweep will be saved. So that's it. This method or this sequence will be performed for each jumper on the site, for alpha, beta, gamma sectors, and for however many jumpers there are in each sector, 1 through 10, 1 through 15, whatever the case is, you perform the same sequence. Now that was just to determine the return loss, to determine if that jumper is good. Now if I wanted to say if we had anything over 20 feet, sometimes the customer likes to know the distance of fault the various jumpers. So if you wanted to find that out, you go back to mode, you go down to where it says DTF. In this case, the customer likes the DTF in return loss mode. So you go down to that feature, you press enter, and the unit will start performing the test. In this particular unit, this test goes back and forth, shoots the frequency or the signals up and down for about 20 to 25 seconds before the results come back. So as you can see, there is measuring and calculating. Like I said, it'll take anywhere up to 30 seconds. The newer units are much faster That's their advantage. They're much faster. Performs this DTF sweep probably in like 5 seconds. So you save time and you get a better display. Like again, I said this is an older model. In this case, on the bottom of the unit, you have where the unit is testing from. In this case, the unit was testing from 0 to 220 feet. This is only about a 20-foot jumper. So I'm going to reset that ending unit 220 to a closer footage so I can see this sweep here, which is now crunched up into a broader form. So I'm going to change 220 to about 40, and it's going to perform the sweep over so we can better see the waveform for that DTF. And again, this will take about 20 to 30 seconds. Unfortunately, this is an older model, so newer models take about 5 seconds. Now we should see a waveform pop up at the bottom of the bottom of the screen, which we did. There's our waveform. Here's our limit line in this case. Now if I go to marker, this is the end of our cable. That will tell me how long this particular jumper is. I'll go to marker 2 because we always want marker 1 at the beginning. As you can see, marker 1 is set up at 0 feet. I'm gonna go to marker 2. I want to edit. So I want to do marker. Well, actually, if I go to edit, I can control it. I am scrolling down my marker 2 to the peak of that waveform right here. Now that's the end of that particular jumper. We're at approximately 14, almost 15 feet. So it's probably a 15-foot jumper. The unit is reading about 14.6. Okay. Now we can see marker M1 at 0. We go out to about 15 feet, and we're well below our prescribed limit line. And in this case, I believe my limit is set at 32, which is the prescribed limit line for this customer. Neg 32, we do not exceed 32. So this jumper passes both the DTF test and the return loss test. And you go through the same saving sequence again, save display. And you can keep the same labeling system with the site cascade, the sector, and J1, because you'll see the difference in the sweeps. This one is a DTF, the other one was a return loss. So it doesn't matter if they have the same naming nomenclature, because once you go into it or get them on your computer, you'll be able to easily distinguish which one is which. And you press enter, and that's it. And like I say, you perform this for however many jumpers you actually have on the site. So that's how we turn on the unit. We select our frequency ranges. We set our markers, we calibrate, we perform a sweep, and save it. Now we're going to perform a system sweep. Basically, it's the same sweep, except this time, rather than going from a calibrated load, we're going to go directly to the antenna. So our test jumper is still connected. We didn't change that. We just added the jumper as if on site to the correct port of the antenna. In this case, we're working the 800 LTE technology, so we're going to the 800 port of the antenna. Okay, so once those connections are made, we're going to go to the test unit. Okay, and we're going to perform the same series, and this is just called the system sweep. So we go to mode again, and we're going to go to return loss, because we want to make sure in this case the actual antenna, which is face down at the moment, test at a 14 dB or better. So we go to return loss, press enter, and it's going to perform a sweep through the antenna. Now in this case, if this waveform which it has exceeds our limit line, that's because our limit line is set up for it's actually set up for a jumper. So what I'm going to do is we're going to go to marker and set this marker to peak. Okay, as we showed before. Okay, we're at a 1544, which means we're passing, but it just doesn't look like it because our waveform is above our limit line. But we'll go to limit, and we're going to limit our edit from 20 to 14, because 14 is passing criteria for the antenna. And now, as you can see, none of the waveform exceeds our limit line, which means this antenna passes the system test. Okay, so once again, we're going to save it. Go to save display, And instead of J1, which we have for jumper 1 prior, we can go for alpha sector, and then we can go to A. We'll just abbreviate A, N, select T, and that's 1 for the 1 port because there are two 800 ports, and press enter. So that means for this site, alpha sector antenna 1 between the 800 900 frequency range, this antenna passes the system sweep. And that's it. We'll perform that for the second port of the antenna, and then the same thing for the 1900 ports of the antenna. And that's how you do a system sweep. You press enter to save that, and that's it basically. Okay, so after performing your sweeps and saving them in your unit, we are now, let's say, into the next day. You're back at the office, or later that same day back in the office. You're going to turn your unit back on. Okay, you let it go through its testing. Okay. Now, to retrieve those sweeps you just performed at whatever site you were on, you push the recall display button, which is also the number 0 on this particular unit, and every sweep you took for that day or previous day should come up. Okay, as you can see, the dates are all listed. Okay, so after performing your sweeps and saving them in your unit, we are now, let's say, into the next day. You're back at the office, or later that same day back in the office. You're going to turn your unit back on. Okay, you let it go through its testing. Okay. Now, to retrieve those sweeps you just performed at whatever site you were on, you push the recall display button, which is also the number 0 on this particular unit, and every sweep you took for that day or previous day should come up. Okay, as you can see, the dates are all listed. So now we're just going to press enter just to recall one. What you see displayed is a saved sweep that we did on site or the day prior or earlier that day. Now you want to go into your laptop. To download these sweeps from the unit to the laptop, you're going to need a serial cable that connects to the back of your unit. Okay, and in most cases my laptop doesn't have a serial port, so I have a USB serial port adapter. Okay, so now I'm going to open my software. Now, to obtain the software for your laptop, you can just go to the Enritsu site and download the latest software possible. I already have this installed. As soon as I find it, we are looking for Enritsu. Excuse me. Let's see where the heck I got it. There we go. Okay, you open your software tools. Okay, now we want to go to capture. Up here in the top toolbars, you click on capture, and you want to say capture plots to screen. Click on that, and we should see the communication attempt. Once you get those blue lines going across, that means it's successful. Okay, now you get every sweep that is saved on your Enritsu unit, or whatever unit you're using, will just be displayed in this box on the screen. These are older, so we just find the date of your last sweeps. You click on that to acquire all the sweeps from that particular date, and those particular sweeps should pop up to the screen. Now, yesterday, as part of this training, we only did 3 sweeps, so those 3 sweeps will pop up, as you can see how we saved them yesterday with our site ID, sector, and our sweep. Okay, it's still going. It's going to download all the sweeps. That should be it. Okay, so now all the sweeps we performed earlier in the day or the day prior are now on your laptop screen. Now we have to label them. As I said, you will label them on the machine or whatever way that fits your, your best fits you, should I say. So I know this is the site ID alpha sector jumper number 1. I can look down here and see it's for the 800 frequencies. So I know which sweep that is. That'll be for each person. Now you want to go to the top toolbar and you go to view. You click plot properties. Okay, now we can start labeling our particular sweep on the screen. So in this case, for network vision, every sweep has to have the cascade. So I'm going to type the cascade to match the top there. In this case, NY 73XC 105. Okay, and it's a return loss sweep, and it was the jumper. So I'm going to label that at the bottom. So it's the return loss, and the jumper was done with a load. So that lets the RF team over at the customer know which exactly sweep this is. For this site, it's the return loss with a load, so they know it's a jumper sweep. Okay, we can erase the site ID again. Here, we can finish the A with the full word alpha, and the J, we can finish the full word jumper, and number 1. So now we know for this site, it's the return loss with a load. It's a jumper, number 1. Okay, our marker should be already set. Okay, now we just click OK. Now you see this sweep is now labeled with the site ID, the test, which is return loss, and with what method? The load. We know it's the alpha sector, and it's jumper number 1. We can visually look at the screen and see it's for the 800 sector. Or what I normally do too as well, we'll go back to the view and make it easier for the RF guys, and we'll label it alpha 800. That way it's easier. Now you see it up here. It's easier for anybody in the RF team reviewing these to see that it's for the alpha 800 side, jumper number 1. And that's pretty much it. All of the other information at the bottom is automatically provided from the unit, from the test unit. That's it. Usually the resolution is 517. It's got the date, model number, all of the information, if the customer wanted to know, is listed on that screen. Now what we'll do, we'll save this sweep. Okay, we'll go to File, Save As, and you just save it to any folder on your unit in conjunction with the remaining sweeps. And that's just about it. You go to Save As and you perform a folder. For all of these sweeps, it can be anywhere from 20 to 100, and you just put them all in there and labeling them this way. Now, the important note is, for a jumper, like I said, we set this up yesterday. We set our limit line at 20. As you can see, our limit line is 20. Now we'll back out, and we'll see this whole waveform in green. Nothing of this waveform exceeds our limit line, so we can easily and visually see that this waveform on this jumper test is good. This blue line is our marker, which is the highest point on the waveform, and nothing exceeds our limit line. So this sweep is good. It's a quick visual to perform to see that this particular sweep is good. And that's basically it. All right, you label each sweep, like I said, anywhere from 20 to 100. You save them in a particular folder, and that's what gets sent off to the customer as part of the closeout.